this is Jason, and he is very handsome. And his initiates is JJ. You can call him JJ or Jason. And he's a researcher in neuroengineer and neuromodulation, and also biosignal analysis. And I think he's the very first person in Taiwan who used MATLAB, and which he is very proud of this. And so what is our lab doing? We normally have a digital therapeutic applications from brain, and we have the neuromodulation called HDTES, and we can observe the brain with the HDTES with the ears, and then we can analyze and compute by the APO cloud. So these will generate like a closed loop for every patient and every engineer. So what is neuromodulation? Normally we can divide it into two parts. One is non-invasive, one is invasive. So normally we're using the TDCS. And how the electrical stimulation modulation works. Normally we have the anode stimulation with the neural activity up, and we have cathode stimulation with neural activity down. So which means that we can manipulate your neuron with high activity or low activity. About the transcranial electrical stimulation. So which part we are going to generate or we are going to manipulate. For example, we can manipulate the motor control, we can manipulate the concentration, planning, or problem solving part. And also we can apply the different modulation method or for example like a pattern, CTBS or ITBS. So what kind of technology we use? We use HDTES in the middle, and this other tools is a different part and different technology. So how we after modulate and after the manipulate, how we gonna observe? We use FNIRS. So compared to the EEG, MEG, or fMRI, so FNIRS is possibly for us to having a wearable system, and we can have a low cost and superficial cortex measurement. So what is NIRS? NIRS is a source with a detector. So we have the source, the laser lighting or LED lighting into the brain. Then we can calculate the photon in the brain, how to penetrate, how they go through. So after neural activations, then we can metabolic demand, and we increase the blood flow. And then in the end, we will have the wash out oxyhemoglobin and deoxyhemoglobin. So how are we gonna do with these two technologies and also the digital therapeutics? First, we will have FNIRS modulate, HDTES modulate the neuron, and we can observe by the FNIRS, and we can have the phone or computer to analyze it in real time. So this is the nearest clinical trial we are using in the lab. So we will have the isometric concentrations, muscle oxygenations, and stimulation with raw EMGs. And then we can have the reference for the torque level. So also we are having the HR app in not only motor cortex or also the frontal cortex. We can see how this gonna work for every part. And this is the technology we developed by ourselves. This is a TES system, and this is the NIRS system. They are all very small, so they can wearable, and we can do it very quickly. So what we actually do in engineering, first we have hardware system development, the electronic circuit design, MCU firmware, and also the FNIRS and neuromodulation part. And then we have signal processing, the FNIRS part, and not only the biosignal analysis, and also like EEG, EMG, any kind of like biosignal analysis in MATLAB or Python. And also now we are also applying the AI into it. And what we are seeking is EPV design for digital therapeutic applications. So very welcome to Taiwan. We enjoy it. Thank you.